yesterday we talked about slope of the line, and we learned about rise over run, and I said you can remember it by saying slope is fun, rise over run. Good. So we're just going to count our rise and run. So here's our rise, and here's our run. Our rise is 2 units. Our run is 3 units. So we're going to say 2 over 3, and we're going to remember that the line's going down, so it's -2/3. Very good. Okay, all right. Number 2, we also learned about the slope formula and how to use that. James?
You have to take the second y, and then you minus the first y, and then you divide that by the second x and minus the first y.
Yeah, there's your slope formula. And so basically what you're doing is you're taking the y from this one and subtracting this one. So it's -2 minus 3. And then I would put the x, so I'm saying -1, or not -1, 1 minus 3. So this would give me a -5 over a -2, and a negative over a negative makes a positive. So this is a +5 over 2, or 5/2. Okay, we talked about that. Typically we do not change improper slope into a mixed number unless we're dealing with something where we need to, like a real life situation, but most of the time we're going to use it just like that, so we don't need to convert it. All right, error analysis. A classmate finds the slope of a line containing the points, explain the error she made in her calculations, and find the correct slope. What's the error, Sophia? -3 is supposed to come before -7. Okay, so we have 9 take away 5. This should be -3 take away 7. So -3 take away -7 would make this plus and make that a +4, right? Which would make this a +1. Okay, good. All right, a climber A climbs at a rate of 14 feet every 3 minutes. Climber B climbs at 19 feet every 4 minutes. Which climber has the faster rate? Chase?
Climber B.
How do we know that?
You divide 14 by 3, and then you divide 19.
How do we know it's 14 over 3 and not 3 over 14?
Because you want to find the unit rate, which is how many every 1 minute.
There you go. How many every 1 minute. That's a good way to explain it. Or you can say that you know that it has to be y over x, right? And x here would have to represent time, and y would have to represent how much they're climbing. And so that would still be y over x, so we would have to do it like that. Tell me some different strategies that you could use to figure out which one of these has the fastest time. Once you get it to this point, what are some different strategies, Gavin? Okay, so that's one strategy. Turn into decimals and check for comparison. How else? Isn't that kind of what they just said? Oh, you mean just seeing how many times will 3 go into 14 and kind of look at that? Okay. What are some other strategies? Okay.
What did she say? You just find the unit rate of both.
Find the unit rate of both, which would be turned in both into decimals. Is that what you mean?
Yeah, well,
okay. Write the decimals. Anna? Isn't that the slope? Would that be 14 over 3? So are you saying could you like graph them both and see which one's steeper? No, because you don't have really 2 points. Yeah, they're just numbers. How else? How else can you compare fractions? We're just problem solving. I'm not saying anyone's right or wrong. You could, sure. Yeah, you could do that too, right? I mean, you could find a common denominator. The common denominator here would be 12, and then multiply the numerators and see which one's bigger. I mean, just different strategies. I'm just saying there's always different ways to do things. I just want you guys to think about that. All right, so let's look at what we're going to talk about today. We're going to understand how unit rates and slope are related. So kind of what the things I wanted to talk about, which we've talked about this, is slope. Slope basically describes the steepness of a line. And and we talked a lot about that yesterday. We talked about how it's used in construction, how they can use it on staircases, how they can use it on roofs, and all of that. So that's what slope is, okay? But then we have this thing with unit rate, and unit rate compares it to 1, but it's also like the same thing as slope. They're very, very similar. And yesterday we talked about, remember we had on our warm-up, it said airplane pilot makes 500, or not pilot, airplane mechanic makes $500 per 1 week. And if you remember, there was a graph, and it showed you how it was 500 over 1. See, that's a unit rate, but that was also the slope of the line. So they're really the same thing when we look at them. All right. So again, when we're doing this today, I'm going to have you go one step further. Not only are we going to figure out what the answer is, but we're also going to figure out what the equation would be, because that will make our next lesson that much easier. So this one says the graph shows the amount of milk needed to make a quantity of butter. This lesson really likes milk. I don't know why. It's not really exciting. Okay, how many gallons of milk do you need per pound of butter? So what do we need to figure out here? Gavin? That's not what I asked for. So what do we need to figure out here? Taylor? The unit rate. How are we going to find the unit rate on here? James? Y over x, which is also our slope, right? So what you can't do is you cannot just look in math and estimate on a graph. You do need to find the exact answer. Now, if I estimate it, we think it's probably 2.5, right? Okay, but we have to use numbers. So our rise here is how much? Wrong. What is our rise? Nope.
5.
Oh,
5. Because it's
right. The graph's going by 5. You have to pay attention to that. So it's technically rising by 5, and our run is 2.
Wait.
Okay.
What?
You mean what? Here's that's 5 over. These are counting by 1s. Now, technically, the only time, if they were both counting by 5s, you wouldn't have to do that, because it would still simplify down. Those of you guys who follow me, that would be like 5 over 10, which would still be 1/2. So if they're the same, you don't have to do it this way, but when they're different, you do. Okay, so how much milk would I need? What was the question? How many gallons of milk do you need per pound of butter? 2.5. Could we write this into an equation? Ashton? Let's just use x and y, because it's on our graphs. Or we could have 5 over 2x. Either one of those equations would be fine. Okay, now I'll tell you, in algebra next year, we will use this exclusively. So it is fine with me for you to leave them as 5 over 2. But in this situation, since we're talking about pounds of butter, it doesn't make sense for me to say, you need 5 over 2. I mean, it would make more sense for you to say 2.5. So it just depends on the problem. Sam? That's a really good question. You know how it always says in blue? You got to follow whatever the blue says. Yeah. Yes.
So unit rate is just the slope, and you just turn it into
As long, yes, as long as it's proportional. See, these are all been proportional also, right? Okay, good. All right, let's look at the next one. All right, the next one says, the graph shows the amount of milk used to make a particular cheddar cheese. Okay, how exciting is this? Okay, like I really want to know, how many ounces of cheese can you make per gallon of milk? Alex?
You can make 16
How did you get 16?
because 2 gallons of milk is 32 ounces of cheese.
So you were using just rash, like you were just using your brain to think about it.
Yes, common knowledge.
Common knowledge. Okay, Chase?
And wouldn't 16 ounces be a pound?
16 ounces is a pound in real life. Yes, it is. James?
Just take 32 over 2. This is 1 over x.
Rise. Slope is fun. Rise over run. Yep. So this is 32. So here's my rise. My run is 2. The reason I do it that way is because if they give you a different one with numbers that aren't so easy to do, like Alex did, you want to have your method down. Okay, so my answer here would be, how many ounces of cheese can you make per gallon of milk? you can make 16 ounces of cheese, which would be a pound, but if they ask for it in ounces, make sure you say ounces. Okay, and then how would I write this in equation then if I want to go one step further? Sophia? Very good. All right, let's look at the next one. Okay, this one's going to change a little bit. More exciting than milk. Are you ready? It's fish food. Way more exciting, right? All right, so your friend has an automatic fish food dispenser. The graph shows how much food is left in the feeder after X days. How much food is being dispensed per day? So what do I need to calculate? What do I need to calculate? Taylor. The unit rate, which is also the slope. Okay, now last hour then this confused them because they said, what do I do?
Oh, I know.
What do you do? James.
Instead of like it was
Okay, I do need to kind of make a triangle out of that. Where am I going to start and where am I going to end? Okay. Where the arrow ends. So you want me to choose, I agree with 20. This is actually called the y-intercept, which we're going to be talking about here pretty soon. So that one. But okay, so again in math, I have to be specific. I have to come up with the right answer. Taylor? Go where? To 5. Where's 5? Here? What point is that? 5, 5? 5, 5. Right there?
Yeah.
Yes, I agree. You are looking for where does the line, these are called lattice points when it goes through the crissy-crossy, like last hour said. That's called a lattice point. So you are looking for where does it go through perfect. So if I look through this line, I don't see any other points where it goes through perfect. Okay? So these are the 2 points we're going to go from. And now we're going to have to find our slope, right? Okay, so what is our slope of this line? Gavin? Nope. -3. How'd you get -3?
You just do the formula. You do rise over run.
Okay, so what's the rise?
The rise is 15 divided by 5, which is 3, and it just goes down. It's negative.
There you go. You guys see it? This would be 15. This would be over 5.
Oh, yeah.
It is decreasing and going down. And so then we're going to reduce this to -3. What does that -3 mean? What does that -3 mean? Jacob?
Decrease of 3.
Yes, it's dispensing 3 grams every day. And so does it make sense why that's decreasing? Yes, because you have the feeder, you filled it up, and a little bit's going out of it every day. So the amount in the feeder is getting smaller. Excuse me, what would the equation be? Eva?
Y equals -3.
Very good, very good. All right, last one I want you to try on your own. Let's see if you can do everything we've done today. All right, so we start off by finding 2 points?
Yes.
Yes. Now there's quite a few more points on this one, right? So you could choose any of these or any combination of those. All of those work, okay? So then I need to calculate the slope. So what is the slope, Alex?
It's 20 for every one. So.
Okay, so when I start off my slope, wouldn't it be 40 over 2? Which does simplify down to 20 to 1. I totally agree, which would be 20. What else do we need to say, Anna?
It's going down.
So it's negative. What if I want to write an equation? Greg?
It's y equals -20x.
Very good. Who can explain to me what this situation means? Who can explain? Sam?
She pays $20 per week.
She pays $20 a week. Okay. Add to that, Chase.
She owes $20 less each week.
Okay, you could say it that way too, James.
She loses $20.
She's losing it to her parents. Okay, Ashton?
It's going to take her 10 weeks to repay her parents.
Okay, and you said how many weeks? Good. So the reason this is going down is because the debt owed to her parents is $20 less per week. Because that's what she's paying. All right, very good.